Okay, so I'm going to assume that if you have clicked on this video, it means that you are ready to talk about the Fundamental Theorem of Calculus Part 2. I'm going to assume that you have already seen where the Fundamental Theorem Part 2 comes from, and that you have written this part down on some index card. This is the important part right here, recognizing that if we have a definite integral from a number to a number, we take some antiderivative, substitute, and subtract. Sub, and subtract. You watched this example, it's canonical. You watched this example, it's canonical. This is the thing people do wrong. They don't recognize that this is x to the negative 2. So normally if we were in class, I would say turn to your neighbor and say, we're not going to do this on test day. You're just going to have to say that in whatever thread you communicate with people in. We did this example. And you have hopefully learned how to do this in your calculator. If you're working with the TI-84, you have to type it out like this unless you have some operating system that allows your calculator to do this. But you should get comfortable with that, and if you don't know how to make your calculator do that, you should pop in during an office hour. We talked about the difference between displacement and distance. If I go to the grocery store and back, my displacement is 0, but my distance traveled is certainly not 0. And hopefully you have sat down and done the 7 questions on the worksheet that I am about to work through. I'm going to work through them a little bit quicker than I would in class because you can always pause and rewind and stop and rewind to get the sense of what we're doing, and to make sure that you can do this on your own. So find the area between the graph of. So this is 3x squared plus 1. That's the x-axis from 1 to 3. All of this area is above the x-axis, so the area is the definite integral. It's the definite integral from 1 to 3 of 3x squared plus 1 dx. The dx matters. And now Fundamental Theorem Part 2 says, here's how we do this. We find an antiderivative of 3x squared plus 1, evaluate, and subtract. So what's an antiderivative of 3x squared? Well, the antiderivative of 3x squared has got to be some version of x cubed because the power goes up by 1. The derivative of x cubed is in fact 3x squared, so we're done here. What's the thing whose derivative is 1? That thing is x. And so now we substitute, and subtract. When we substitute 3, that's 27 plus 3. When we substitute 1, that's 1 plus 1. We subtract, answer is 28. This is fairly standard. This is actually one of the easier questions I could possibly ask you. This is on the same level. What's the integral from 2 to 8 of 1 over x dx? So we find an antiderivative of 1 over x, substitute, and subtract. Your question asker gives it away. The thing whose derivative is 1 over x is the natural log of x. So we substitute, and subtract. Substitute, and subtract. You are asked to give your answer as the logarithm of a single number. Well, when we subtract logs, that means we divide the numbers. This is the natural log of 4. Now, unless your calculator has a fancy computer algebra system, your calculator is not spitting that answer out for you. So you've got to know how to do that to get the right answer. I'd like to work on this also. We find an antiderivative of e to the 2x, sub, and subtract. What would the antiderivative of e to the 2x have to be? Well, we know that the derivative of e to the x is e to the x, so we're pretty sure that our answer is some version of e to the 2x. But then we remember when we take the derivative of e to the 2x, that's e to the 2x times 2. And we don't have a times 2 here. So we need a number out in front that neutralizes the times 2. And you can check that this is a function whose derivative is e to the 2x. So then we substitute the 4, substitute the 1, and subtract the answers. No way to simplify there. Some people are going to say that this is 1/2 e to the 6th, but those people are wrong because we don't do anything with powers when we're subtracting. Okay. Question 4 was a calculator active question. What's the least positive value of k for which the area under y equals cosine x? Here's cosine x. From 0 to k, here's k, is 0.2020. There are lots of values of k because the cosine function keeps coming back around and around and around. So there are lots of values of k. There's one here, there's one here, there's one here, there's one here, there's one every 2 pi the rest of the way because of how the cosine function behaves. So we want the first one. We want the least positive value of k. So how does this work? Well, we know that the integral from 0 to k of the cosine function is 0.2020. So how do we find this integral? Well, we would take some antiderivative of the cosine function, some function whose derivative was the cosine function. Sub, and subtract. So we substitute, and subtract. Oh, the question author was nice to you. And then you remember when you were in high school and you did 1,000 worksheets that asked you to solve things like this? Well, that was for this day. Your calculator does this for you, and you round to 3 decimal places. So what do you need to know? You need to know that area is connected to definite integral, and you need to know antiderivatives, and you need to know how to use your calculator. This question I used my machine for. I literally set this up in my calculator and used those different values of x. So I did the integral from 0 to 1.35, x squared minus 2x dx, integral from 0 to 1.38, x squared minus 2x dx, and I got a bunch of values. I got negative 1.0024, negative 1.0284, negative 1.0567, hope that's a 6, and it could be an 8, and negative 1.1098, and then I used those same values of x here and did the integral from 2 to 1.35 of x dx and the integral of 2 to 1.38 of x dx and so on, and I got negative 1.0888 and negative 1.0478 and negative 1.0060 and negative 0.9048, and sure enough, that's bigger that's bigger, that's not bigger, so that's the answer that we want. Very much that question is there so that you know how to use your machine. That's what the question is there to ask you. Love questions like 6 and 7. They are roughly the same. In questions 6 and 7, you're given information about one function value and asked for another function value. And f is an antiderivative. So every time you have an antiderivative and two particular inputs, you're thinking about a definite integral from 2 to 6. So if you do the definite integral from 2 to 6 of this function, what does the fundamental theorem part 2 say about that? It says that if I'm looking for the definite integral of this function, I take an antiderivative, sub, and subtract. And f of 2 is 0. So when we're looking for f of 6, we just find this definite integral. The calculator does this for you. This is not something we do by hand. The calculator does this for us, particularly because we see those words. And so that's approximately 0.331. Okay, this is the work you'd show. That's the answer you'd get. And the similar thing happens down here. Again, we have f being some antiderivative. We know about 1. We want to know about 4. So we're thinking about an antiderivative, an integral from 1 to 4. Integrals and antiderivatives are inextricably linked. So we know that the definite integral of e to the negative x squared dx, that's f of 4 minus f of 1. We know what f of 1 is. So we also know what this is because the calculator gives it to us. That's about 0.139. So f of 1 is 2.020. And so we can use this equation to figure out that f of 4 is 2.159. If you do not know how to use your calculator to make this spit out and how to use your calculator to make this spit out, swing by in an office hour. I am more than glad to help you. Okay, that's our 13 minutes. Thanks for swinging by.